Yeah, that's what I just did. Word problem. Word problem. It's time for word problems. Yeah. Form it. Try and form pair simultaneous equations from this and then solve it. I didn't call it an equation because I think we've had some experience with forming equations. Let's see if we can put those ideas together. You know, you've done a bit of work on forming equations on in task 40, what was it, 44. Let's see if we can put together the idea of forming equations with this work to actually form a pair of simultaneous equations and then solve it. Try on. Go on, do it. Come on. Power the pause. You've worked on the question, and you know, I just want to say sorry. I just reflected on my behavior, and I was thinking, you know, was I a little bit too pushy there? I'm sorry. Okay, if I was a bit too pushy, you know, come on, do it, you know. But no. You gotta try. Get stuck. You learn from your mistakes. Oh yeah. Sorry. Come on. You gotta try. You have to have a go. Most you can do is get it wrong. Power the pause. Got you. Please try it. Please, pretty, please. Okay. Right. You've had your chance to work on this problem. I'm gonna do it now. Let's do it together. Make sure if you've done it, make sure you've done it the right way. You got your right model, you got a right solution, and then we have a few more of these for you to try. Okay. So ticket machine sells travel on a tram, sells tickets. So we're doing tickets, and a single ticket costs £1. £1. A single ticket costs £1, and a return ticket is £2. That makes sense. Double thing. Yeah. In one day, the machine sells 100 tickets. So what you want to do in a question like this is we have two things we're talking about: the number of tickets sold, and that's what we want to find out, how many of each ticket type are sold. So we have the number of tickets, we have information. There's 100 tickets in total, 2 different ticket types, and then we have some information about the prices, the amount of. So we can make one equation about the number of tickets, and then another equation about the value of those number of tickets. To do that, what we'll do is, and at GCSE level, you don't have to write this extra bit, but it's beautiful and it makes things clearer for yourself if you write it. But I would declare my variables. I would say let X be number of single tickets, and then I'll say let Y be number of return tickets. And I'm so thinking, why did we have to do all this writing? A question with all this writing. I should have typed it up. Yeah, but so I'm telling you what X and Y is, and hopefully I want to just, you know, for me this is when algebra becomes more useful, because you're actually thinking, well, all of a sudden I know what X and Y is. It makes some sense now. X is the number of single tickets, Y is the number of return tickets, and we can make our first equation. Well, how many tickets did the machine sell? It sold 100 tickets. So X, the number of single tickets, plus Y, the number of return tickets, has to be equal to 100. Number of tickets 100 doesn't tell you what type. So all the singles plus all the returns give me 100. Now, in terms of cost, if I buy, then this is how that's my equation 1. My equation 2, if I bought one single ticket, I'll cost £1. 2 single tickets, £2. So it's going to be X. The number, if I bought 5, if I told you 5 single tickets, it's going to cost 5 times 1, £5. I don't need to write the 1. X is just not just the number of single tickets, it's also the cost of the single tickets. If X, the number of single tickets, is 50, then you're spending £50. Yep. For return tickets, it's a bit different, because for every return ticket, I have to pay £2. So if I bought one return ticket, it's going to cost £2, 2Y. If I bought 2 return tickets, it's going to be 2 times 2. 2Y will give me 2 times 2, which is 4. Substitute in the value of Y. You buy 10 tickets, it's supposed to cost £20. 2 times 10. So 2Y is the term. 2Y is the term that represents the money you make from selling return tickets. And that, when I add up the total amount of money the ticket makes selling, so the money made from single tickets plus the money made from the return tickets, I have to get 172. Those are your 2 equations. question like this will definitely, we're into 4-mark territory on an exam. Why? Because you had to form the equation, that's worth something, and then solve it. Now, if you weren't able to form the equation, hopefully you're happy at what I've done there, and you feel, yeah, I can form this equation. I want you to solve it. I want you to go on and solve this now. Go on, solve it. What we already have the same number of x's. I'll do that work on the side here. And this, again, big numbers, so fair enough, calculator. But if I was to do 2 has bigger numbers, so 2 take away 1. I'll just jump into that because we already have the same number of x's. The x's are going to be eliminated. So now I have to do 2y take away y, which will give me y. And then 172 take away 100, which will give me 72. So that's where that's coming from there. Just continuing there. Y is equal to 72. And then now that we know y, we can quickly find x. X is going to be equal to, because remember, so we're doing substitution in 1. If I sub in 1, x plus 72 has to be 100, which means that x is 100 take away 72, which is equal to 28. Okay? So that's your strategy there. And in terms of how many of each ticket type, in an exam, they would probably have single tickets equals return tickets, but we'll write it. Singles, 28. And then the returns, we sold 72. Those are the answers that you have there. How do you feel about that? Is that what you did? You feel, yeah? If you didn't, if that's not what you did, think you can do this now? Let's do another. That's the only way we're going to do another one of these. So you got this new question here. Same idea. Probably see how you get on. I'll give you the model in a moment, but pause. You have a go. You do it. I'm not going to solve it. I'm just going to give you the model. And then I'll give you the answers as well. I'll give you the answer. That's how we'll do this here. Right, you've had a chance to work on it. So let's just build on this here. The bus stop, 2 places. Bus stops at 2 places. The fare at the first stop is £3, and the fare at the second stop is £5. When the bus sets out, there are 38 people on the bus, and the driver has collected 158. So, and we want the number of people that get off. Interesting wording, yeah? How many people get off on a bus? You know, modeling this, you gotta really understand the language. How many people get off the bus? Okay, so we're thinking about people. X, what can be X? X can represent the number of people on the bus. Number of people, how are you gonna write it? We have to say what we're gonna let X be and what we're gonna let Y be. Okay, I'm going to give you a moment to think about that, and to help you think about it, let's leave the formalities a little bit and see how we can build an equation from this information. Okay, what do we actually know? We know how many people are on the bus in total. Do we know that? Yeah, we do, because when the bus sets out, there are 38 people on the bus. So one of your equations, and then we'll tidy up what we'll write for x and y. One of your equations is going to be x plus y is going to be 38. And if x plus y is 38, you're thinking, well, what's x, what's y? What we can agree, it's people. Yeah, let x be number of people doing what? And y be number of people. What's the difference between the people that we're calling x and the people we're calling y? You get where I'm coming from there. So that's equation 1. And then equation 2, it's going to be about money, yeah? Equation 2 is going to be about money. Let's just read. So we're going to look at this money, and he's collected, so 38 people set off on a bus, and he collects 158 pounds. Let's see. First stop. And you ready to write in what x and y is now? Giving you a chance. You've had a chance. What's x? What's y? Number of people that get off at the first stop. Get off at first stop. And then the number of people that get off. Y is the number of people that get off at the second stop, because that's the difference. We got people, 38 people on the bus. Some are going to get off on the first stop, so they're paying one price, and then some are going to get off on the second stop and they're paying a different price. And so we got two types of people on the bus: first stop people and second stop people. Total number of people, number of first stop people plus the number of second stop people have to add up to 38. And then the number of, for every first stop person, I'm going to get £3. So I'm going to write 3x. If it's one person getting off at the first stop, I'm going to get 1 times 3, £3. If it's two people, I'm going to get 2 times 3, £6. And then the number of y is the number of second stop people, people getting off at the second stop. Second stop people sounds a bit more interesting. Ooh. So the second stop, it's going to be 5y. 5y is what we're going to get there, and that has to end up to 158. That's the equation you want to be solving there. X plus y is equal to 38. 3x plus 5y is equal to 158. So off you go, you work that out. Should have called it equation 2. And you work through what you will get for that one. You work through what you'll get for that one. And note what the question is asking. The question is very specific. How many people get off at the first stop? That's what the question is asking. So I'll pause. You had the equations. If you weren't able to form the equations, you have another equation to solve? Yep. Right. Let us now give you the answer. The answer, what do we want to find? The answer to the question, is it the value of x or y? They're asking for the number of people getting off at the first stop, so the question is asking you for the value of x, and the value of x you should have got, x equals 16. 16 people got off the bus at the first stop. That's what I'm reading. That means we don't need to, and note, that has implications for how you would have done this question, because you do not need to find y. Hint, hint, I'm not going to do it. I've just mentioned that you didn't need to find y in this question. Not sure how you did it. Did you multiply by 3 or did you multiply by 5? I would say that if you multiplied by 5, you would have got the answer faster, because you wanted to find x, so you needed to eliminate y and get x and stop. You did not need to find the value of y. But there would be incredible value to finding the value of y. And it's quite easy to do. I mean, as soon as you know x is 16, then y has to be 22, because 16 and 22 would give you 38. And that would allow you to do a check in equation 2 to see if you'll actually get the 158. So although I'm showing you a way to get x first, which is the answer you want, in terms of checking, you would want to have the two values and check an equation 2 if it actually works out. 16 times 3 is 48. So 16 threes, I can check it quickly. 16 threes, 3 times 16, which will give you 48, plus 5 times 22, which will give you 110. So 48 plus 110, which is 158. So we know it's going to work out, okay? Because we're working on the basis if x is 16, y is equal to 22. And that's the level. Look at what I did. I went further. I didn't just stop. I got the answer, x is equal to 16, but I checked. And that meant doing a fair amount of finding y, which the question didn't ask me to do. But something like this, that's 4 marks in an exam. Put in the effort, make it happen. I'm going to leave another one for you. Pause, you have a go, and let me pop in the answer for this one. This one is an interesting one to model, something to talk about. It's just about understanding steady stream, steady current, and how something moves. The equations you should have will be V. I've done the power of the pause. You should have the equations V plus C is equal to 3.7, and then V take away C is equal to 1.3. Those are the equations that you need to solve. The reason why? What's the reason why? Should I say the reason why? You're adding and then taking away? Yeah, I will say it to finish. And I'll give you the answer. The final answer was you would get that V is equal to 2.5 and C is equal to 1.2. Those are the solutions. So that's the equations and those are the solutions. The reason this model works, ready for it? How do you move? You have a speed. The speed plus the current. The current of the water is pushing you. So when you're going upstream, the current is pushing you upstream. When you're going downstream, sorry, when you're going upstream, you're working, I said it the wrong way. Whoa. When you're going upstream, you're working against the current of the water. So it's your speed, take away the speed of the current, that will give you the overall speed, which is 1.3. When you're going downstream, think you're running down a hill, you're getting pushed, the stream, the current is pushing you down. So there's a real life element of this. You have your speed, and we should say, and what actually said, anyhow, we'll leave it at that. You have your speed, your velocity you're traveling at going in this direction, and the current, when you're going up, the current is working against you. So that's why we do a takeaway to get to 1.3 upstream. Going downstream, you have your speed going down, and the current is working with you. So the added value, you get that extra boost to go faster downstream. Here is another one for you to try. Go on, build your model, see what you come up with. Yeah, go on, power a pause, and you work through this one. While you're doing that, I can, have coffee, drink. I can't have a coffee actually. No, this is not good. My coffee cup is empty. Ooh, empty. Right. So okay, you paused. Right. Okay. Right. So you've had a chance to work on this. I haven't had a chance to have a coffee. That's life. The model you should have, X could be the number of adult tickets, and Y could be the number of children tickets. So that's the idea you want. X adult tickets, Y children tickets. In terms of mathematical model, then we're thinking about X plus Y is equal to 300. And then 5X plus 4Y is equal to 1,444. Those are the figures. I'm pulling these figures in the interest of time. Your job is to solve these pair of equations, and in terms of solving them, the figures you should end up with would be X being equal. So X is adult tickets. X adult tickets, you should write it a lot nicer than this. Let X be the number of adult tickets, and Y will be children's tickets. Okay, so that's the model we're looking at. The children tickets are £1 cheaper, 20% off for children's ticket. And your answers, once you have your model, so that's marked there, and then the actual answer is X is equal to 244. So predominantly adult tickets have been sold, and Y is equal to 56. Those are the figures that you should have for this one. Let's move on. Here's another one, and with some interesting twists to it. But go on. Again, you have a chance to build a model, use that model to come up with a solution, and then now we have the chance to adjust the model after in light of new information. Power the pause. You're working through this one. 5, 3, 2, 1, 0. Okay, so you've worked through it, and what are we looking at here? In terms of modeling, there's different types of banknotes. So number of £5 notes, X £5 notes, you would write let X be the number of £5 notes, and then Y, let Y be the number of £10 notes. That's what we're thinking about there. And in terms of your equations, then you have X plus Y is going to be equal to 200. That's one of the equations there. And then the other bit, well, the value now plays a role. So for every £5 note, I have £5. For every £10 note, I have £10. And when I add up those values, I should get 1,395. That's the original equation. Those are your original equations. So in terms of finding out the value of each of the notes, X and Y, when you solve those equations, that's a 10 there. My 10s are looking more like 6s, but that's your equations there. And the solutions, let's just read. What you're going to have is X is going to be equal to 121. So 121 £5 notes. That's the £5 notes. And then y, I'm getting y as 79. You make your checks, but I'm reading off from my screen, and that will be the number of 10-pound notes, so 790 pounds there. The adjustment, what needs to change? If it is that it's 1390, what's changed? It's 5 pounds less. It's 5 pounds less. So how do you accommodate for that? For 5 pounds less, how do you accommodate for that? Well, what's the adjustment you made? The overall value has to be 5 pounds less. What needs to happen? You don't need to redo the equation. Y needs to become 78. If you do y is going to be 78, that's a further reduction in 10-pound notes. So that means you went down 10 pounds if you do y is 78. And then if you do x is equal to 122. So in terms of 5-pound notes, you increase. You're adding 5 pounds. The effect of taking away 10 and adding 5, that will be a reduction in 5 pounds. So in other words, what we've done is minus 10 plus 5. Minus 10 plus 5 is a reduction of 5 pounds. So that's the whatever did he made. He counted different wrong notes. That would be a suggestion there that he miscounted the number of notes. And we've adjusted it. It actually should be, we needs one less 10-pound note and one more 5-pound note. He mixed up one of the notes. Yeah, counted what am I saying? He counted let me see if I get it right. What did he do? You get it? He counted a 10-pound note when he should have counted a 5. Yes, I got it right. After all of that hard work, let's think about the USA. Oh yeah, the USA. Oh yeah, oh yeah. Time. Not going to build a model on this one. Just going to give you an answer at the end. But you have the power of the pause. You work it out. You work out this one. And we'll wrap up on this one. Word problems, enjoying, modeling. One of the most valuable skills in maths. 10, 9, 8, 7, 4. I'm going to the USA. New York, New York. Yeah, yeah. New York, New York. Yeah, yeah. New York, New York. New York, New York. Right, okay. Let's see what we're doing here. You had the word problem. You had to figure out your model. The answer you should get. The length of the flight length. 9 hours. And then the last bit, the time difference. 5 hours. So definitely he traveled from the UK to the east coast of the United States, which has that 5-hour time difference. I can't say for sure he went to New York. Could have been Miami. Going to Miami. But the Eastern, so yeah, Eastern time, that would be 5 hours behind. If he was going to California, I'll leave you. You got your internet, etc. You can see if you were flying from the UK, going all the way over to California, what would be the time difference? America, just for your information, America has three different time zones. It's that big. Has Eastern time. Am I getting it right for you? Yeah. Has the Eastern time, New York, Miami, those places. Then it has Central time, I think. I'm not sure. Texas runs on Central Time, or Chicago. Central Time, and then there's Pacific Time, which is what places like California. So California, I mean, by the time you get to the western end of the United States, you're starting to think about heading to Australia and Hawaii and heading across to the Pacific Ocean. So Pacific time on the far west of the United States. 3 different time zones. Big place. Right. Hope you enjoyed. Bye-bye for now.